CockroachDB is a distributed database written in the Go programming language. We'll analyze how CPU time is distributed inside a running CockroachDB server. Run the top command to check the CPU usage. As shown, this process consumes more than 250% of CPU cores. Let's run the ps command to see more details about this process. We can see it is the standard CockroachDB binary executable shipped with the Linux distribution. Let's use OpenResty-X-Ray to check out this unmodified process. We can analyze it in real time and figure out what's going on. Open the OpenResty-X-Ray web console in the web browser. Make sure it is the right machine you are watching. You can choose the right machine from the list below if the current one is not correct. Go to the guided analysis page. Here you can see different types of problems that you can diagnose. Let's select high CPU usage. Click on Next. Click on By Processes. Select the process that consumes almost 200% of CPU cores. This is what we saw previously in top. Make sure that the application type is right. Usually, the default should be correct. The language level here is just Go. We can also set the maximum analyzing time. We'll leave it as 300 seconds, which is the default value. Let's start analyzing. The system will keep performing different rounds of analysis. Now it's executing the first round. The first round is done and it's already on the second one. That's enough for this case. Let's stop analyzing. It automatically generated an analysis report. This is the type of problem we diagnose. It's CPU. The Go runtime's garbage collection takes about 13% of CPU time. This Go code path created about 25% of the total number of new GC objects created. Currently executing is an anonymous function created in the function runAsync task X. It's used to manage the lifecycle of various asynchronous tasks in the CockroachDB system. Click to see more details. This hot code path is automatically inferred from this Golang GC objects allocation flame graph. Let's enlarge it. Continue to zoom in. This hot code path consists of three main parts: the KV-Chord package, the RAF protocol, and the SQL MUX component. Click to enlarge KV-Chord/dist-sender. KV-Chord is a key value coordinator module in CockroachDB. It handles concurrent access and data consistency, and responsible for coordinating concurrent operations between multiple KV client instances to ensure data correctness and consistency. Click to enlarge the start function. Raft is a distributed consistency protocol used by CockroachDB for data replication and fault tolerance. CockroachDB is a distributed database. It uses multiple KV server nodes to provide high availability and scalability. Zoom in the SQL MUX function. SQL MUX handles routing and multiplexing of SQL requests on CockroachDB's nodes. These are the other code paths that allocate the most GC objects. This is the second GC object allocation path. In the CockroachDB SQL layer, the makeExecPlan function creates a query execution plan. Take a look at the third GC object allocation path. Calling nextAdapter also creates a large number of GC objects when processing a stream of column data. Now we see the fourth Go code path. The execute statement function also creates a lot of GC objects during execution. GC object collection takes up nearly 10% of CPU time. OpenResty-X-Ray can also monitor online processes automatically and show analysis reports. Go to the Insights page. You can find the reports on the Insights page for daily and weekly periods. For this reason, you don't have to use the guided analysis feature. Though guided analysis is useful for application development and demonstration purposes. OpenResty-X-Ray is a non-invasive diagnostic system based on our own dynamic tracing technology. It can monitor and scan performance problems, behavioral issues, and security vulnerabilities in real time. If you like this video, please subscribe to our YouTube channel. Thank you.